Hi. It was a few years back that I started making this software for simulation of fluid systems. But since then, I've developed the animation aspect, the component, and we'll see the benefits of that in the video that I'm making now. Just for your information, if you want to contact me at sometime in the future, then my email address is there, and we can go over any thoughts that you have about the software and how it could be used. Okay, so the simulation package is it's simulation, control, animation, design, and training server. The simulation is developed in a object-oriented way, written in C#, and it's really designed for engineers that have a good familiarity with the concepts of numerical solutions. But it doesn't require any software you don't need to develop any software. The software is there. This is a user interface that makes it easy to develop engineering design. You just need to be familiar with the nature of control and fluid systems, thermodynamics, and control. The control aspect is related to first of all custom devices that I've already developed. So for instance, pressure control valves, controlling the downstream pressure using the mechanical aspects of the valve. But as you'll see in relation to animation, the control can be done outside of the system, because the system is based on the concept of using a relational database as the shared memory. And because it's shared memory, then any company can develop the control sequences, control algorithms, and interface to the simulation software via the relational database. The only thing that needs to be done is for the user to be familiar with the fields of the tables and the fields of the database. As far as animation is concerned, I've developed that quite significantly, and now you'll see the benefits of it. It's written in Python, and Python has just become a bit of an eye-opener for me. With its selection of libraries, it makes it a lot easier to create the animation that I expect, and make it realistic, so that the user who isn't familiar with the engineering concepts so much can then see the benefits of the simulation and become a vehicle for training, for education, for design. Obviously the design aspect comes from the engineering diagrams that need to be developed in order to create the engineering solution. And as I said, it's a good vehicle for training. So let me continue, and we'll see where we go. So now we're into the engineering aspect of it. So you sign in to your account, you select a project, each project can have a set of systems, and we'll be checking out this particular circuit. So each system can have one or several circuits, and we'll just check the environmental state, and these are the fields. I won't bother to go into those. Okay, so once we've selected the circuit, then we select the controls associated with the circuit, and we go into run mode and start. Okay, now excuse me having to go through the different pages here, but this is the animation that I developed associated with that particular engineering system. So what we have is a loop circuit which is being fed by 3 pumps, each of which has a check valve, and then along these particular points there's a line that feeds out to atmosphere with a manual valve associated with each of those lines. Okay, as you can see, there's the arrows indicate the direction of flow. Now, since there's no pumps running, one would expect perhaps no flow, but the engineering model includes the gravity head of the tanks. So there's a gravity head from each of the tanks, and there's enough pressure in order to provide a minimal flow from the tanks through to the tank that's being fed. Now, each of the switches controls one of the valves or one of the pumps. So if we start with this particular pump, this is pump number 1, and if I select the switch, then the pump starts and the check valve opens, and now we're providing fluid through to the tank from this particular pump, because each of the check valves for the pumps that are not working are closed, preventing any more fluid traveling through the lines through to the tank. So, and if, for instance, I open up this valve, which is valve number 1, then you can see the flow of fluid traveling through the manual valve out to atmosphere. This is the only pump that's operating. The check valves are still closed, and all the fluid is coming from this particular tank and diverting, splitting between the 2 lines here, and then through to the 3rd line here. And we can do the same thing with the 2nd valve. So again, we can see the direction of flow and the way in which the flow splits up accordingly. Now if we start the 2nd pump, so this is pump number 2, the check valve closes, the pump starts up, and now instead of the flow going only to the tank, this particular pump is now splitting and then feeding the flow to this valve here. And as you can see from the arrows, it shows the changing direction, and that is really significant, because dynamically you can see how the flow moves between different devices. Now, this is a typical system. It's a difficult system to simulate, but the animation is really full of information, as opposed to an engineering diagram, which also provides the same sort of information, obviously, but you have to have a sort of an engineering knowledge. But any of the information within the database that is being updated by the models can be extracted to the animated schematics that I have here. And the software for this is designed in Python, and it's an object-oriented design, which means that the logic for the pumps, for the for the globe valves, for the tanks has all been developed, and that each of these devices can be instantiated without a significant problem. Now, you would say, well, this sort of software is available, but this is totally flexible. It's the animation can be sort of developed for any type of diagram, and the other aspect of it is, and this is the main aspect of it, is that the information for these diagrams comes from the database, and the control of these devices. Say you had a valve that needed to be controlled from a complex algorithm designed by a control company, then if that software was available in any language that had access to a MySQL database, which almost every language does, then that software can be used to update the relational database and consequently be able to simulate and animate the nature of the control. And so therefore it can be used to validate control sequences, control algorithms, feedback control systems, the lot. So I think it would be benefit. I think people will be finding it interesting from an educational point of view. I think it can be quite fascinating for people. And I'm hoping that a company will be interested enough to become involved, and we can see where it goes. Okay, appreciate your help. If you want to contact me, my email was at on the front page, and hopefully I'll speak to you soon.